Hello, welcome. In this short video, let us look at an example illustrating that the minimum variance unbiased estimator derived using the linear model assumption fails when the dynamic properties of the unknown parameters are not taken into consideration. That is, when the model has dynamic parameters, we cannot apply the linear model assumption for the static parameters to derive the optimal estimator. So consider a model where we have x of n is equal to a of n plus w of n, where a of n is the parameter of interest and it is a dynamic parameter. That is its value changes with the time, and w of n is of course the noise component, which follows a Gaussian distribution with mean 0 and variance sigma square. We treat this problem as a static parameter problem. That is, if for n observations we can say that we have n unknown parameters and use the linear model x equal to h theta plus w, where h is the identity matrix and theta is the parameter vector a given here. Then we can use theory for parameter estimation under the static parameter assumption. We have that a hat is equal to h transpose h whole inverse h transpose x. In this case, the observational matrix is the identity matrix, so we have a hat is equal to x. That is, the minimum variance unbiased estimator is the observation vector itself, which is clearly undesirable. That is, though the expectation of the observation vector or the expectation of the MVU estimator is equal to the true value, however, the covariance is given by the covariance of the observations. So we do not really gain any information from this estimation methodology. The main reason why this estimator is undesirable is because the covariance of the estimator is same as the covariance of the observations. So the reasons why this estimator fails is because we have only one observation corresponding to one parameter. So there is no averaging of the observations to reduce the noise or to nullify the effect of noise in the parameter estimation. And moreover, we model the dynamic system as a static system. I ignore the temporal relation between the parameters. That is, a of n is definitely related to a of n minus 1 and a of n plus 1 is definitely related to a of n. So if we ignore that property, we are basically not able to estimate the temporal evolution of the parameter. So in order to improve the performance, we have to basically consider the dynamic properties of the parameter. So the problem is similar to a case where we have single observation and we have a single unknown parameter. Then in that case, the optimal estimator is the observation itself. However, it is not sufficient. Basically, it still has the same variance as the observation. We do not really gain any information about the unknown parameter. So now let us look at a plot which illustrates this problem. The red plot basically shows the unknown parameter which evolves with time, and the blue plot shows the DC level estimates, which are basically the observations themselves, which has the variance much larger than the variance within the parameter. This problem results because of the ignorance or because of ignoring the dynamic properties of the parameter. Thus, in order to estimate the unknown parameters or unknown dynamic parameters, we have to basically take its dynamic relation into account. Thanks for watching.